Right. So today's lesson is going to take a couple different components that we've been working on and put them together. And so it's a combination between what do you know about the signs of the unit circle and the quadrants of the unit circle and how that affects the sign and the quantity of the other coordinate and value in that coordinate. So let's just look at what I'm talking about on that one. Let's look at quadrant 1, right? Common thing to pay attention to in quadrant 1 is that both the x or cosine and the sine or y are positive in this quadrant. Pretty fundamental component. It's like, okay. So if I was to say that cosine theta equaled 1/2 and was in quadrant 1, so what is the value of sine theta? You could say, okay, well, then it's going to be positive, because if we're in quadrant 1, then it also has to be positive. And it'd be radical 3 over 2. Right? So, and the reason why we kind of say that is, if you notice, if we come down here, if I was to just say cosine theta was equal to 1/2, what is the value of sine? Honestly, if you were to look at this, you have two options. Sine could either be positive radical 3 over 2, or it could be negative radical 3 over 2. So both of those would be technically correct if all I gave you was this information here and didn't tell you which quadrant. So if I was to say cosine theta equaled 1/2 and I'm in quadrant 2, well, here, or excuse me, not quadrant 2, 1, 2, 3, 4, quadrant 4, then you would say, okay, my sine theta must equal negative radical 3 over 2. So once you get this 2 bits of information, you can zone in and find the missing quantity. So it's kind of like hints. And we're going to give you a couple of hints, and with those 2 hints, find the missing value. So how does this compare to over here? Well, let's say I said cosine theta equaled negative 1/2. Be like, all right, well, if that's my x quantity, so that means it can't be in quadrant 1 or quadrant 4, because everything over here has a positive x. Whether the sine is positive or negative, the x or my cosine is positive. So if I say cosine is negative, that automatically means that I must be dealing with either quadrant 2 or quadrant 3. And that's going to determine whether my sine is positive or my sine is negative. So if I was to say cosine theta equals negative 1/2 and is in quadrant 3, what is your sine? Then you can be like, all right, now I got both of those bits of information. My sine is negative radical 3 divided by 2. So with these 2 bits of information, not only knowing what the theta equals and whether you're dealing with cosine or sine, and knowing its quadrant, you can find the value of the missing coordinate. So let's see what this kind of looks like if I was to apply it with the sine factor. Alright, so I'm going to say, use blue, I'm going to say our quantity that we're looking for is sine theta equals radical 2 over 2. So, all right, sine is my y. Y is radical 2 over 2 when it is here, and here when it is positive. Otherwise, down here it's negative, so that's not my options. So my question is it quadrant 1 or quadrant 2? And that would tell me what my cosine. What is my cosine? So I'm going to say quadrant 2. So the question is, what does cosine theta equal? Negative radical 2 over 2. So with these two bits of information, you can find this other one. Right. So sine theta equals negative 1/2. I want you to take a second and look in and see, all right, what two quadrants can I be looking at if my sine of theta equals negative 1/2, my y equals negative 1/2? Can you tell me what cosine is? Could you tell me what two possibilities cosine could be? All right, quadrant 4. What is cosine? And there you go. All right, so we're going to take this bit of information and apply it to what we're doing of the Pythagorean identity and solve it algebraically without a graph. So one other component that we need to be able to make a connection to before we move on to the algebraic component is this concept here of the range, that you're going to see things that says given 0 less than theta, which is less than pi over 2, or you might see something that says pi over 2 less than theta less than pi, etc., or some weird combination thereof. And what you have to be able to do, and this would be great if you have this copied down or make your own notes as to what basically is what, but note that if theta, which is our angle, that's just a fancy word for given a degree or an angle, is between 0 and the radian pi over 2, then that's the same initially. It's code for saying in quadrant 1. Okay? If it's saying pi over 2 to pi, that's code and can be translated for quadrant 2, and etc., that all of these can indicate which quadrant it is talking about that we're going to find the value of our x or our y or a sine or cosine. Now note, something might say given 0 less than theta, and it might go all the way up to 3 pi over 2. And what that's saying is that it could be quadrant 1, quadrant 2, and quadrant 3, but it's not in quadrant 4. So that's kind of when it's giving you these what more than one quadrant it is, what quadrant or quadrants it is not. So make sure you make a note of those, excuse me, as to this is fancy way of saying quadrant 1, this is just a fancy way basically of quadrant 2, and etc., etc. So note that, and that's going to come in handy in our next section. Let's take these different concepts and let's put them in an actual math problem to solve. So let's say I'm given sine theta equals 0.766. where 0 is less than theta less than pi over 2, and it wants you to find cosine. So we're going to be using this formula here. So if you need to go back and watch that video regarding the Pythagorean identity, please make sure you do so. But otherwise, I do have them. And again, it's basically just that. It's basically the Pythagorean theorem of looking for C, but in this situation, it's sine or cosine. And so we are going to take that information, and since we're looking for cosine, we're going to take our sine. Here's my formula, and substitute it in. So it's just the radical of 1 minus our value of sine squared. We're going to square it, and that will get us our 0.587. And we're just doing math at this point. We're just plug it in and simplify. But what we come down to is that cosine could be positive, is approximately positive or negative this quantity. So basically I've done everything that I can do here using my formula. Now I'm going to start looking at my where component. So it says that it's this range here. So that means that I'm working with quadrant 1. And since it's quadrant 1, that means I'm going to be having a positive x and a positive y. Well, cosine technically is my x, which doesn't matter because they're both positive. So my actual cosine is going to be positive 643 thousandths. Okay?
But since I use a poison apple on the poison apple.
Example. Cosine, though, this time, and this is our where pi is less than theta less than 3/2 pi. So we're looking for sine. So since we're looking for sine, this is going to be our formula that we're going to use. So we're going to take our cosine and plug it in. And I want you to actually go ahead and pause the video and work through it and see what you get, and then play the video and check your answers. So it's a great opportunity to do guided practice. Please remember this is a negative. When you square it, you're going to end up with a positive number. So it'd be 1 minus still that positive quantity. So go ahead and pause the video and work through it. All right. Otherwise, we're going to go ahead and show your answers. So that's it squared. That's it subtracted. We're going to take the radical, which means we have a positive or negative answer option. We then refer back to our quadrant to help us narrow it down as to where it is. So we know that cosine is negative, so that gives me 2 options. But this is, from pi to there, is quadrant 3. Quadrant 3 is a negative and negative quadrant. And so thus that means that sine is going to be negative. Excuse me. So that's the assignment. That's the work, and that's the information behind it. All right. I hope this helped.